Chapter 6 is all about quadrilaterals, and today we're going to talk about a special kind of quadrilateral, a parallelogram. Okay, parallelograms are a quadrilateral with two pair of parallel sides. Okay, parallelogram, parallel sides. It makes sense. So a quad with two pair of parallel sides. Okay, so when we're talking about the two pairs of parallel sides, the sides that are parallel to each other are opposite. So if we look on our picture here, we show that sides are parallel with an arrow. Okay, notice they're going the same direction. Okay, the other pair of opposite sides are also parallel, but they're not parallel to the other two. So we're going to put a double arrow on those sides. Okay, let's talk about different properties that parallelograms have. Okay, the first thing is we're going to talk about our diagonals. Okay, when I have a diagonal of a quadrilateral, what I'm doing is connecting the opposite vertices with a line segment. Okay, that's known as the diagonal. Okay, and we can draw two in here. Okay, what's special with parallelograms are the diagonals actually bisect each other. Remember, bisect means to divide into two congruent pieces. Okay, so if we want to mark that in our picture, we're going to say that this segment is congruent to this one. Okay, but if you notice, this first diagonal looks shorter than this longer one, so when we say that this segment is congruent to the other one, we want to put two tick marks on those one because it's not the same as that first length. Okay, other properties we should talk about are the side lengths. Not only are the sides opposite each other parallel in a parallelogram, they are also congruent. Okay, notice we've got one tick mark and two tick marks. This is an entirely different length, so we're going to put 3 here for that, and opposite will be exactly the same. So our first property we're talking about, opposite sides are congruent. Okay, now just like that, the other pair of sides are congruent to each other, and we're putting 4 tick marks there because none of these have to necessarily be the same length. Okay, so we want to show that. Okay, we've talked about sides. Let's talk about the angles in a parallelogram. Okay, just like opposite sides, we can say that opposite angles are congruent to each other. Okay, so there's one pair of opposite angles that are congruent. Okay, and then we have another pair. Again, just like with the sides, this angle here does not have to be the same as that one. In fact, if you look at this picture, they don't even look like the same measure. So we're going to put 2 arc marks there. One more thing about angles. Another property we have with parallelograms is if you take any 2 consecutive sides, consecutive meaning in a row, they are going to add up to 180 degrees, or they are supplementary. Okay, so any 2 sides that are next to each other are going to add up to 180 degrees. So consecutive angles are supplementary. Okay, any one of these properties so far that we've talked about alone is enough to tell us that we are working with a parallelogram. Okay, we don't need to know all of them to know that this would be true. Okay, the last property that we're going to talk about is just one other way we can tell that a given shape, a given quadrilateral, would be a parallelogram. And that is if we have one pair of sides that are both congruent and parallel. Okay, so if we know that one pair of opposite sides, so like the top and the bottom here, if we're told that they're congruent and that they're parallel, that's enough for us to tell that it is a parallelogram, which would automatically make the rest of these true. Okay, so let's use these properties to talk about whether or not we can tell a quadrilateral is a parallelogram or not. Okay, so on number 1 here, we have some information. We're told that this length is 6 and the opposite of it is 6. Since they're the same number, those two sides are congruent. Then we are given a 4 and a 4. Both pairs of opposite sides are congruent, so that tells us, yes, we do have enough information. This is a parallelogram. And why? Because the opposite sides are congruent. Okay, now on number 2, we've got another way to show that sides are congruent. We've got tick marks here, so we know that this one pair of opposite sides are congruent. But notice we're not given any arc marks on this side or any numbers. Because we're not given that, and we're not told that these sides are parallel, like property number 4 we just talked about, we don't have enough information to know whether or not these are parallel or not. So then we don't know if it is a parallelogram. So we're going to say we don't have enough information. They could be parallel, or they could be the same number, so it could be a parallelogram, but we're not given that information, so we can't say that they are. Okay, for number 3, we're given some angles. Notice here, opposite each other, those two angles have the same arc mark, so they are congruent. Same way here, we've got a single arc mark in opposite corners. So that means that the opposite angles are congruent, both of them. So this, yes, is a parallelogram. Okay, that is our second property up there. Okay, so that is enough. We can say that the opposite angles are congruent. Okay, now let's talk about number 4 here. Okay, notice we're given two side lengths. We've got the top side is 5, the bottom side is 5, and then we're also given the diagonals in here. Well, what's special about these diagonals, notice on one half of the first diagonal we've got one tick mark and a second tick mark on the other side. Okay, what that tells us is that this second diagonal split it into two congruent pieces. Okay, that means that it bisected it. Okay, is that true about the other diagonal? And in this case it is. Now, in the case of diagonals that bisect each other, that is enough information by our diagonals under your properties there to tell us that this is a parallelogram. Okay, so we can say yes on this one because the diagonals bisect each other. Okay, for the next one we're going to skip down to number 8. It's right directly below the one we just did and talk about it. Okay, notice it looks kind of similar to number 2. We're given two pieces, two tick marks here, and that again means the two sides are congruent. Okay, let's check out what's happening with the other side. On problem number 2, we weren't given any information, but in this case we were told that this side was 8 and this side is 10. Okay, well, to be a parallelogram, we have to have both pairs of opposite sides being congruent. And in this case, one of them is, but the other one is not. So this is not a parallelogram, and it's not that we don't have enough information. Okay, it's because these sides aren't congruent. So we can say that the opposite sides are not congruent. So this thing is not a parallelogram. Okay, take some time, pause the video, and work on 5, 6, and 7. Okay, and then check back to see if you came up with the same answers. So number 5 here, we've got two sides. They are consecutive. Okay, our properties say nothing about consecutive sides, so we're going to say that no, they're not enough to tell us because there is just not enough info. We don't know anything about the opposite sides, so we can't tell if it's a parallelogram or not. It could be, we just don't know. On number 6, yes, because those tick marks mean that the opposite sides are congruent, and that is enough. And lastly, number 7 here was a little bit tricky. Okay, assume a lot to begin with that this might be not enough information, but we know something from last time about quadrilaterals in particular. All of them, the degrees in an interior the sum of the interior angles in a quadrilateral is going to add up to 360 degrees. And that's because we've got 4 sides, so 2 times 180 is 360 degrees. Now if that's true, we can say if this was x here, we've got 110 plus 70 plus 110 plus x equals 360. So this combines to be 220, add another 70, and that's 290, plus x equals 360. And then when we subtract that 290 over from both sides, okay, that means our missing angle there is 70 degrees. Now is that enough information to decide? Okay, we could say that opposite angles here are congruent, so yes, it is a parallelogram. Or if we look at these two, we know that the consecutive angles are supplementary because they add up to 180. Do they add up to 180 there? Yes. 180 again, and 180 again. Okay, so yes, and for either reason, opposite angles are congruent, or we could say that the consecutive angles were supplementary. Okay, so for these last problems, okay, what we're going to do is work backwards. We are told that the shapes are parallelograms, and if they are parallelograms, they are going to have all of those properties that we talked about at the beginning. Okay, that means opposite sides that are congruent, opposite angles that are congruent, consecutive interior angles that are supplementary, and also diagonals that bisect each other. Okay, so using that, we want to fill in any missing measurement. So for this first one, we are told that this is 10, so that means the opposite side better be 10. Okay, same idea here. If this is 12, we know the opposite side has to be 12. So that's talking about sides. Now if we look at the angles, we are told that this base angle here is 80 degrees. That means that the angle opposite of it better be 80 degrees. Okay, but it wants us to find all of the missing measures, so we need to go and figure out what this angle would be and this angle would be. We know they have to be the same because opposite angles are congruent. We just have to go find one. Okay, well we could use the idea of the angles in a quadrilateral adding up to 360, or we can use this property that we learned today. Okay, consecutive angles have to be supplementary. Okay, so if these two have to be supplementary, that means they have to add up to 180. So we're looking for 80 plus x to equal 180 degrees. Okay, solve for x by subtracting 80 from both sides, so that x has to be 100 degrees. So this will be 100 degrees there, which makes this bottom angle over here 100 as well. Okay, if we check out number 10, we can easily fill in that this is 10 up here as well, and this is 18. Okay, but when I'm looking at the inside, let's do sides first. This 8 represents this section right here, and we know that parallelograms, okay, the diagonals bisect each other. So that means if this is 8, this down here also better be 8. Okay, same idea with the other one. This side of this little triangle on the inside, or half of the diagonal, is 11, so that means that this better be 11 as well. Okay, well the only other measurement we're given is this 71 degrees. Let's see if we can use that to figure out some information here. If this is 71 degrees, there's one right across from it. That's known again as vertical angles, and we know that vertical angles are congruent to each other, so that will be a 71 degrees as well. Okay, then the only other thing we need to come find is this angle and this angle. Okay, well if you notice, these two angles have a special relationship. Okay, notice they are next to each other and form a straight line, so they are a linear pair. Okay, and linear pairs are supplementary. So if we take 180 and subtract 71 from it, we can get 109 degrees, then use the vertical angle theorem to know that that is 109 degrees as well. Okay, I told you that that was the last angles that we had to go and find, because for us to find this angle and this angle, we would have to have more information. Okay, if we look at these triangles here, notice we're missing this and this. We have two unknown angles, and we don't know anything about them, what their relationship is. So we can't assume that this is x and this is x to go find the missing angle. So we are done on number 10. Okay, number 11, pause the video, go ahead and take care of that one. I think you can handle it. And then check your answers with mine. Okay, across is 14, across from the bottom is 20. We've got an angle of 115 degrees. This one, remember, is supplementary, so we've got 65 degrees here and 65 degrees here to cover all of our missing pieces. Okay, if we take a look at number 12, again, all of these are parallelograms, so we know opposite sides, opposite angles are all congruent there. So let's look at this. Here we're just given sides, so we know this is 8. This would have to be 8 as well. Okay, so what we can do, if this is 2x, but it's also 8, we could say that 2x is equal to 8. So then we can solve by dividing by 2 on each side. X equals 4. Okay, so we found the missing side, found the missing variable. Let's do the same thing for the other side. This is 10 down here. This better be 10 up here. So we can say 5y is the same thing as 10, or it's equal to 10. So that means y equals, divide by 5 on both sides, y has to be 2. We found all the missing measurements on that. Okay, let's check out 13 here. We've got a lot more missing pieces here. Okay, notice what we have added in here that we haven't talked about yet is this dotted line that's going here. Okay, and if you notice this dotted line, it's going from the top of your parallelogram to the bottom. This top and bottom are what is called the bases of a parallelogram. Okay, and the height is if you extend a perpendicular line from base to base, from a vertex of your base to the other side. Okay, notice it's at a right angle. It has to be at a perpendicular. Okay, so the height of this parallelogram would be 4. Okay, so if this is 4, then we can tack a 4 over here because these will be the same height. Okay, let's talk about what we know. So we'll deal with the sides first. If I have a side of 5 over here, I know that this right-hand side has to be 5 as well. Okay, but if we take a look at our bases, at our top and our bottom here, okay, we're not directly told what the total length is. Okay, but we are told that this is 5 and this smaller section is x. Okay, well, if you notice, if you go down here, we've got an x as well. Okay, we can drag this 5 down. Do you agree that this length of 5 is the same as this here? Okay, we still, again, don't have enough for the total length, but let's see if we can go find what that x value is. If you take a look at where the x is located, it's along the bottom here, and what's formed is a right triangle. Well, we know something special about right triangles. Okay, we can use the Pythagorean theorem, or a squared plus b squared equals c squared, to find a missing length of a right triangle. Okay, well, in this case, our missing length is one of the legs, so we want to put x in for a or b, does not matter, and then our other leg length is 4. Lastly, our hypotenuse is 5, so we're putting that in for C. So if we simplify, 4 squared is 16, and 5 squared is 25. If we subtract 16 from both sides, we get 9. And lastly, to get x by itself, we have to take the square root of both sides. So x equals 3. And we can go and put that in our picture here. Okay, well, if you notice this triangle in particular, 3, 4, 5 is something you should recognize. That is one of our Pythagorean triples. Okay, if you, before you did all this process, recognize that as a 3, 4, 5 triangle, you wouldn't have to do all this work to go find that 3. Okay, but we still haven't found the total length. If this is 3 and this is 5, that means the whole thing would be 8, which makes the whole thing 8 up there as well. Alright, we took care of all the side lengths. Let's talk angles. If this is a 53-degree angle, we know that up in this corner we will have a 53-degree angle as well. And last thing, if this is 53, we know this angle here must be its supplement, or an angle that adds to it to make it 180 degrees. So if you take 180 degrees and subtract 53, we get 127 degrees there, and this one will be 127 degrees as well. So we've taken care of all of the missing parts for that one. Okay, pause the video and see if you can figure out all the missing pieces for number 14. Okay, so if you take a look on this one to find the missing side length on the left here, we use the Pythagorean theorem again, but this time our missing side was the hypotenuse, so you wanted it by itself. Okay, you do all the work for that and you get a 29. Okay, this is actually another Pythagorean triple. We just don't use it as often, so it's not one we necessarily recognize as easily, but it is one that you will see. Okay, so if that's 29, the opposite is 29. Okay, we can drag down this 23 here and combine those two to be 43. Same thing up here. This is 20 down here. We've got a 20 up there to match. So our bases have a length of 43. Okay, the height we can drag directly over. Remember, this dashed line means the height of the parallelogram. Okay, and lastly, we just have to talk about those angles. We are given 46 here, so we've got a 46 there. Subtract that from 180 to get 134, and we've taken care of our other opposite angles.